Welcome back to another episode of the Block Runner Podcast. I'm your host, William, always here with your co-host, Iman.
What's going on, dude?
On the sticks, we got TJ.
Hello.
And finally, today we got Bob Bodily joining us from Bioniq. He's a founder of Bioniq. He's an all-knower of things ICP.
Yes.
Thank you so much for joining us, Bob.
Yeah, really happy to be here.
Yeah, man.
Excited to chat, chat as deep as we want to go.
Yeah, we've been wanting to have you on for a while now. I think a few months ago when things were really popping off, like new layer twos were emerging, and the big discussion and conversations and debates in the space was like, are these first attempts legitimate? Are they scams? Are people just trying to get away with like a new hot narrative? So like, we really need Bob to kind of like dissect all this. But, we're busy guys, so things kind of like didn't manifest. But here we are. It's like, oh, wow, TAP makes this recent announcement. It's like, whoa.
Yeah.
There's an ICP TAP protocol integration coming in the horizon. We're like,
and just to be clear, we're talking about TAP right now only because we have a metaprotocol built on TAP. And then all of a sudden, Benny makes an announcement that they're partnering with ICP and they're going to be leveraging a lot of the technology. So, like, the perfect person to explain ICP has to be Bob.
Yeah.
And
so before we get deep into those weeds, I guess for our audience who might not be familiar with, I guess, your background, your work, and like your expertise, how all that came about, if you can just kind of give us like a quick rundown on how you became a part of the space and, are able to kind of like understand and contextualize everything so well.
Yeah, so me and a couple of friends tried to build ed tech app on Bitcoin. Sorry, not on Bitcoin, just on chain. We wanted to try to do a fully on chain ed tech application. This was like in 2017. It was a bit early to try to do something like that. The tech didn't really exist. It just wasn't really possible. But this idea of, open, permissionless, censorship-resistant storage or compute, or just generally applications or for the internet is, I think, really appealing to a lot of people. And so started building on ICP full-time in May of 2021 and built for a long time on ICP, built a lot of different tech, and then I've been building full-time on Bitcoin since February 6th of 2023. So that was about 2 weeks after the 0.4.0 release of Ordinals. And, when it came out, I started seeing the traction and I was convinced that Ordinals were going to be massive. I had all of the individual pieces that you needed to have a vibrant, successful ecosystem.
Yeah.
And so started building lots of Bitcoin tech. It was pretty synergistic because ICP has a lot of interesting protocol primitives for Bitcoin directly. And so it was kind of a really nice transition for us with everything happening with Ordinals and BRC20 and Runes and other meta protocols and just the growing interest in Bitcoin. It made a lot of sense for us to build Bitcoin tech on ICP. So we've been doing that since early February of last year, and it's going really well. We now have a fully functioning Ordinals marketplace. I might call it an Ordinals L2 marketplace. It's technically not an L2 marketplace, but it's the closest thing we have right now to an Ordinals L2 marketplace. So, you can do fast trades. You have the full programmability of a, smart contract platform. You can do, fast transactions. You can do other cool things. So yeah, that's kind of the, brief version of my history.
Yeah. Well, after like a year and a half in the space, like, so what is your general like sentiment takeaway? Like, looking back, I guess, since you got involved directly with Ordinals and I guess what's happening now with Runes and such, if you could make like a critique on anything, like there's anything you would have changed? Are we headed in the right direction as far as like a Bitcoin ecosystem? The culture that's emerging, do you align with it? Do you think like there's something wrong in any way? Like, what do you think so far?
Generally, I think my response would be people want to do more on Bitcoin. And we've seen this with meta protocols, with Ordinals and all the other meta protocols. We've seen it with sidechains. We've seen it with people trying to build L2s, rollups, ZK rollups, sovereign rollups, optimistic rollups, BitVM. It's very clear that there's a large section of Bitcoiners that want to do more on Bitcoin. and I applaud this. I think, I'm against Bitcoin ossification. I think we need to make Bitcoin better for the world. And that's what we're seeing. We have a really decentralized Bitcoin layer space right now, as lots of people try to build interesting things on top of Bitcoin. So I don't really have any complaints. I mean, if I had to complain, it might be because of the 2017 to 2022 period of Bitcoin, where we kind of just lost a lot of time, I think. But since then, I mean, I'm really, really pleased with everything that's happening. I love the push to upgrade Bitcoin with OpCat. I think CAT helps everyone. And I think there's a lot of interesting tech being built that's going to make Bitcoin more usable, more programmable for everyone. So generally very pleased.
Yeah, I think we have like the same.
Yeah, I would think so. I mean, as far as like when Ordinals started, I think we found it like maybe sometime in February, and then we didn't really get deep into it until March. When we found it, I mean, I feel like what has happened is what we expected to happen for the most part. Yeah, I think the most interesting thing that I wouldn't have predicted is so many metaprotocols. And I knew that there were so many that they were eventually going to, for the most part, just die off. And the meta protocols that allow developers to kind of build on top of it would be the ones to survive the storm, if you will.
Yeah.
And that's largely what's happened. And I think there's just a handful of meta protocols that have persisted through the ups and downs.
Yeah.
And I think that was the ultimate like takeaway. Like if I were to assess things, what do you think?
Yeah, and not just that. Like I guess my early assumption was at some point, I don't know, there would be some more maybe pushback against things like indexing reliances and stuff like that.
That's true.
I don't know. I felt, especially specifically for Bitcoin, because we were new to this like community. I guess we were from Ethereum for the last 4 years, right? I know Bitcoin has like a really diehard decentralization like ethos behind it, right? So, there is a little bit of like a centralized dependency in this meta protocol space, and I know you have like a lot of things to kind of like say about this, like how we could potentially address this in the future. What's your personal opinions on that? Like the actual like architecture and infrastructure of this like development space.
Yeah, I think meta protocols are fantastic because you move compute off chain, which is really nice because Bitcoin has a really limited compute environment. Yeah. And so moving it off chain gives you a whole bunch of flexibility over what you can do. And so meta protocols kind of thread this needle of, let's use Bitcoin as a full data availability layer. We're preventing reorgs because, we have the security and decentralization of Bitcoin. And then let's have indexers go and run, pull through all those messages and run all the compute. You could even do smart contracts. You could have EVM smart contracts on chain that you then run the compute in your indexer. So lots of really interesting things with meta protocols. The downside is you have this point of centralization now where you're trusting an off-chain indexer to know if you have a balance. Bitcoin itself doesn't know anything about these balances directly. And then you also don't really get any scale. You don't really get any scaling benefits. You don't get like a 20x decrease in cost or an improvement in throughput or anything just by using meta protocols alone. So that's kind of the downside of meta protocols. Yeah. I think there's an interesting future. Sometimes I call it the ZK future. This is assuming we can build ZK rollups on Bitcoin and ZK tech matures enough to where it's, essentially you can build a trustless L2 directly on Bitcoin. At that point, it's hard to imagine that you really need anything else other than that. Yeah. If you have full programmability, you can issue assets and everything inherits the decentralization and security of Bitcoin. I mean, what else do you want? It would be faster. It would be cheaper. It would be, inherit, it would be trustless. It would inherit the full, decentralization of Bitcoin. So yeah, in this theoretical, ZK future, there's a chance that you don't need anything else other than that.
So what is it that we have right now? Like, because I hear a lot of existing, I guess, L2s that are emerging or whatever you want to call them. Like, they say there's a ZK ZK is on the roadmap, right?
Yeah.
So is it actually purely like a theoretical thing, or have some of these teams, to your knowledge, figured out like a direct pathway to integration?
Yeah, so there is one team that claims that they can do a ZK verifier right now on Bitcoin, but it's like, I'm not even going to say who the team is because an extraordinary claim like that requires extraordinary evidence.
Yeah.
And we just don't have any evidence to support that yet. Everyone else there's this general consensus that we can't do it right now, and here are the things that we would need. We would need something like covenants, and we would need some other kind of verifier component. And so I know people are working on this right now. I know that BitVM 2 has some interesting possibilities around this, but it's most likely that we need a Bitcoin upgrade with CAT or some other opcode in order to enable this kind of functionality on Bitcoin. So if ZK rollup is on your roadmap right now, it's essentially a asterisk, pending a Bitcoin upgrade.
How likely do you think the OpCat upgrade is going to happen? What would you say?
I always like to bring up Udi says it's going to happen this year for sure, 100%. And then I asked Jeremy Rubin, also brilliant developer and author of CTV, which is the check template verify opcode, which is another really good contender, I think, for a Bitcoin upgrade. And he said 3% chance per year for the next 10 years, essentially, independent events. So that's essentially about 25% chance in the next decade that we get CAT into Bitcoin.
So help us, walk us through, what does it take? Like, what is it going to take to actually upgrade to OpCat? Is it going to take a software that miners just decide to adopt because they agree with this upgrade, or how does it work? Like technically?
Yeah, the Taproot wizards put out the best. So the Bitcoin improvement process is actually pretty nebulous. It's actually very hard to understand exactly how Bitcoin actually upgrades. The Taproot wizards put together what they call BIPLand.
Yes.
I don't know if you've seen it. It's just quantumcats.xyz/bip-land.
Yeah.
And they essentially walk you through the, let's see, what is it, 21 steps to to upgrade Bitcoin. And it's kind of a satirical take where they make jokes at all of the, Bitcoin Core team and the points of centralization along the way in Bitcoin Core. But essentially, I wanted to glance through, I'm just looking at it right now.
Yeah.
There is a point where you get to the soft fork stage. Where is, I'm just glancing through it.
Yeah, because like from my perspective, I thought it was basically a software update that miners would have to opt into, and it seems to be more complex than that.
Yeah, we've heard.
Yeah, there are. Yeah, go ahead.
No, I was just gonna like we've heard, the Bitcoin Core thing. Like during the early days of Ordinals, there's like a core community of developers that were not very favorable of like what this was doing.
Pictures on Bitcoin.
Yeah, so it got us to thinking like, who are these individuals, like, or these entities?
Yeah, how do I get onto the email list?
Right.
Yeah,
so you're right. It is a nebulous thing, especially if we're not familiarized with it. We never actually directly witnessed an upgrade happen. We weren't paying attention when Taproot occurred, right? So,
well, we were paying attention during SegWit, and so it's very similar.
Yeah, but dude, we were like,
we're
fresh.
Yeah, we're minnows.
Exactly. Yeah. So, yeah, I don't exactly know how that mechanism applies as well. I'm assuming it's just some early contributors to Bitcoin. We're talking like early days. They just never really gave up their position of, I guess, contribution since then, right? Yeah. So they just kind of like run things internally, right? So I don't know. I guess is there anything that that you could tell us as far as the process that you understand to these improvement proposals?
Yeah, so there is a history here. If you look at how SegWit and Taproot were added to the network, there's something called a user-activated soft fork. User-activated soft fork, you can read about. I need to do more digging on this myself, but it's essentially the activation time of a blockchain soft fork is enforced by the full nodes, which are commonly referred to as the economic majority. So user-activated soft fork is one way to upgrade Bitcoin.
Okay.
There is, what is the other way? Is it just a hard fork?
Yeah, that's essentially what happened with Bitcoin Cash. They did a hard fork, and then they made updates to the consensus protocol as well, and then the size of the blocks.
Yeah. Well, I mean, so yeah, it definitely sounds difficult. Like not like a
this is non-trivial.
Yeah, this is not. Yeah, exactly. So us developers looking to expand on what's already like happened over the last year and a half with ordinals, whatever fungible token meta protocols. We're left in like a weird like gray space. Like we don't exactly know what the future looks like to, like you're saying, to scale our applications, to scale our ecosystems, whatever. How are we going to support an actual user-friendly environment, right? So, we talked about things like Stacks. Stacks has been around for many, many years. Things are emerging like Merlin, like a layer 2 and others similar like it. And then Benny has introduced us to ICP, and you as well. Like we've seen you kind of like champion this idea that we could leverage ICP to kind of like do all these things that we need as developers, right? So if you can, just give us like the intro elevator pitch, like why us devs should really consider this like, strongly.
Yeah, so let me give you the quick breakdown on ICP. Initially, when you hear about ICP, it's likely in the context of it being some kind of like VC dump, pump and dump, scam coin, price down forever, whatever. The launch wasn't great. There was evidence of some like FTX manipulation with, releasing some perp trading a couple days before, pump up price and then shorted it all the way down. But beyond that, if you actually look into the tech is absolutely fantastic. And I think this is why Benny has is looking to use some of this tech, is because the tech is really, really good. ICP is, if I had to, boil it all down, it's it offers decentralized compute, hosting, and storage. So it's like decentralized web services.
Okay.
If you think about kind of the progression of blockchains, you have Bitcoin as a store of value, medium of exchange. You have Ethereum, which adds on kind of a layer of compute. Obviously, there's like decentralized storage aspects built into these two networks. And then ICP is trying to kind of, round it all out, where you not only have storage, you not only have compute, but you would also have web hosting. So think things like hosting your front end on the blockchain, or storing your website assets, back end and front end, full stack on the blockchain. So that's what ICP is trying to do. It's like the decentralized web services blockchain. And so they make a bunch of different trade-offs compared to what Bitcoin and Ethereum have done, and even like Solana and other blockchains, in order to try to accomplish this objective of, allowing anyone to build a full stack application entirely on the blockchain. So that's the, quick version. Happy to dive deeper wherever though.
Yeah. So according to like the actual technical application of a full stack on blockchain, from what you can tell, I'm assuming that this is actually viable. That you can have like the internet computer is not a meme name. It's an actual representation of like the direction of the technology. So it's actually viable to put the entire back end and the front end on the blockchain.
Yeah, I mean, a lot of people make fun of it because it has such a bland name, like Internet Computer Protocol. Like, could you have picked 3 more generic words to represent a blockchain? Like,
Yeah.
I don't know, probably not. But the goal was, how do we build a decentralized world computer that can be accessible, permissionless, censorship resistant, affordable, and how can we offer, all of these web services, compute, hosting, storage in a way that can, like any internet application, could deploy entirely on this stack.
Yeah.
And so you end up with this really generic name because they're trying to build this protocol that is essentially an extension of the internet. It's trying to add this decentralized world computer, computing layer, storage layer, hosting layer into the internet itself, essentially.
Yeah. Okay, so I'm more curious on how the Bitcoin blockchain and ICP interact with each other directly. Can you go into detail, as technical as you want to get? Because I'm interested in like how leveraging ICP actually adds to the security of Bitcoin. There's still transactions happening on Bitcoin even though you're using ICP. Like, tell me a little bit how all that works.
Yeah. So I would say that there are 3 main protocol primitives on ICP that make it easy to build Bitcoin tech. One of them is there is a Bitcoin light node running fully on chain on ICP. So what this means is there's a set of nodes. ICP breaks up all of their nodes into subnets. So it's a subnet architecture. It's a sharded architecture. And you only do consensus within your subnet. So there's a set of nodes, there's a subnet of nodes on ICP that make calls to a whole bunch of Bitcoin nodes and get block data. Then they pull all that block data in, and there's like a round of consensus that happens. And then you have essentially verified the Bitcoin block data. And then they make that available to all smart contracts on ICP. So the nice thing about this is essentially like a Bitcoin block oracle of sorts. Like you no longer have to try to go grab data from a Bitcoin node or grab data from off chain somewhere, because it's all been brought on chain now. So with a simple smart contract call, you can read what UTXOs a particular address has and what their balance is.
That's cool.
And this is a really, really nice feature. In coordination with that, you can also broadcast your Bitcoin transactions directly through that integration. So you can broadcast out. So you can also make a Bitcoin transaction in an ICP smart contract and broadcast directly through that Bitcoin integration, the Bitcoin light node. So that's the first protocol primitive. The second one is called threshold signature subnet. So we have, one of these subnets that does the Bitcoin node, Bitcoin light node. We have another subnet that does threshold signature subnets, threshold signatures. So what this means is every node, I think there are 28 or 30 or 31 nodes in this threshold signature subnet. And threshold signatures means you need a certain number to actually have a valid signature. So you don't need all signatures. Which means that you don't have like a synchronicity assumption. You don't need all nodes to be online at all times.
Sure.
Whereas with like a multi-sig setup, you do kind of have this liveness assumption. So you have this threshold signature subnet, and a certain number of them sign, and then currently it is a threshold ECDSA implementation. That means that you can make ECDSA signatures using this subnet. The nice thing about this is ICP smart contracts can now hold Bitcoin. You can give ICP smart contracts can have a Bitcoin address and can hold or escrow Bitcoin. So you have the full programmability of ICP, and you can have Bitcoin associated with this ICP smart contract. So it's almost like on Bitcoin, you can lock up funds in a particular script address, and they can only be spent in a certain fashion, satisfying certain conditions. You can essentially do that on ICP, leveraging this TCDSA subnet, but you have unlimited programmability essentially on the ICP side connected with, escrowing those funds in a Bitcoin address. So that we can go deeper there. A lot of the Bitcoin integration ideas on ICP relies on this threshold signature subnet. So we can come back to that one, but that's the second kind of main protocol primitive.
Okay.
The third one is there is a wrapped Bitcoin on ICP called CKBTC. This is essentially you take Bitcoin, you send it into a Bitcoin address that's controlled by the CKBTC smart contract, and it mints you a token like a one-to-one token on the other side.
Sure.
And ICP, because of the sharded nature of the subnets, it has like 3-second finality and very, very low fees. I think it's like a 10 sat fee. And you pay all of your fees in Bitcoin directly. So there is CKBTC as well as the wrap version of Bitcoin. And then other teams have leveraged these primitives to build. In our case, we have an ordinals bridge that leverages this same tech. So you can take an ordinal and you can bridge it over. And Bioniq actually uses CKBTC as the main currency.
Mm-hmm.
And then ordinals, in their bridged fashion can then be traded very quickly, very cheaply on Bioniq. Someone else has also done this with runes. So you can take runes and you can store them in one of these ECDSA Bitcoin addresses, and then you can transact with your runes tokens in a fast, cheap fashion on ICP. So those are kind of the key protocol primitives. I know that was a lot, and I went through it quickly, but we can go as deep as you want.
Oh yeah, I'm following. So can you explain the differences between a signature threshold and kind of like using Bitcoin natively on ICP versus using a wrapped Bitcoin like CKBTC? Like why have those two? They seem to be the same, or am I wrong?
Yeah, so you can create Bitcoin transactions directly, like L1 Bitcoin transactions. You can create those directly from an ICP smart contract.
Right.
So that means you can just interact directly with Bitcoin itself. The benefit, so that's, I might call that like a direct integration maybe, because you're actually interacting on Bitcoin itself from an ICP smart contract.
Yeah, and let me pause you right there. So it sounds like it's more of it is a direct integration, but it's like a programmable version of Bitcoin, right? That signature threshold.
Yeah, it's kind of like DLCs in a way.
Sure.
Because you can programmatically control the flow of Bitcoin, essentially.
Okay.
It is all on Bitcoin L1, so everything moves at the speed and cost of Bitcoin directly.
Okay,
and
so
that's essentially points to the reason why you would perhaps want to bridge those tokens over to the ICP side.
That's exactly what I was going to say.
Yeah.
Yeah, so to answer my own question, so then the reason why you would want CKBTC was to increase the speed, reduce the cost, and sort of use kind of like the native value proposition of ICP without the baggage of like the slowness of Bitcoin.
Still, couldn't there be like an intermediary period where just to leverage the programmability, independent of like the scaling part, right? Just because that in itself is still a need.
That's what I'm thinking too. Yeah.
Yeah, I feel like that's a good like first attempt at like a showcase of why this integration is important. Like if we can have much more, dynamic assets specifically for like metaverse apps and such like that, right?
Sure.
So it's a big deal if we can kind of like get some of these products online, just to kind of like. It's okay for now while things are still slow and expensive, but it kind of like paints the picture of that, like that integration for Bitcoin, right? And then, that's like a meta protocol-esque thing in itself. I mean, it might not be interpreted as such right away, but it can nurture like an ecosystem as a result, and then it can scale it down the line.
Yeah, and then if you're leveraging CKBTC, you're sort of having to trust somebody, right, with your Bitcoin.
Yep.
I don't know.
Right.
Yep.
Yeah. And so with this threshold, the signature threshold, you're not really. It's my own Bitcoin wallet, right?
Yeah.
And it's attached to this programmability aspect to it.
Yeah.
And so I feel like that's a huge value add.
I think so too.
There, there are similar trust assumptions between these two ideas. Because if you want to leverage the programmability, generally you'll have to take your Bitcoin and you'll have to deposit it to a TCDSA Bitcoin address. So this is not like a Xverse Bitcoin wallet, for example. This would be like kind of akin to a smart contract wallet.
Okay.
A smart contract wallet idea is that the smart contract, this is, very popular on Ethereum, and actually a lot of people are starting to build smart contract wallets. In fact, some of the best wallets in the future, I think, will be smart contract wallets because they just give you so much more flexibility over the existing kind of seed phrase, wallet, browser extension, current wallet paradigm. But in a smart contract wallet, you would have control over your funds, but you are trusting the smart contract nature of that wallet environment. What I mean is you would still have to trust this TCDSA subnet, the nodes running the subnet in order to leverage the programmability, even if it's just Bitcoin L1 transactions.
Can you give an example of the failure of this trust and what could happen if there is a malicious actor within the subnet, and what could they do with these assets inside that wallet?
Yeah, I mean, I would say it's very similar to existing implementations of Bitcoin bridging, like TBTC is probably the closest. There's still some differences here, but TBTC uses a threshold implementation as well to bridge, but you are essentially giving full trust to this threshold signature implementation. Full trust meaning they could freeze your funds, they could steal your funds. And so it's similar to a multi-sig. I would call it like a really, really good multi-sig, but you are still trusting someone else with the custody of your Bitcoin. And so it's not, it's not a pure Bitcoin L1 play.
Okay, I see. That makes sense. Yeah, because at first I was thinking, it's like, well, you could generate a Bitcoin address that is sort of trustless, where you have your 12 to 24 words, but it's attached to this mechanism of programmability where that Bitcoin can be moved based on conditions, not just on you signing a signature, right? But it seems to me that the smart contract wallet has private keys in some server that can be leveraged and used to spend your money, essentially.
So the private key lives in the threshold signature subnet.
I see. Okay.
The Bitcoin would have to live in an address where the private key is. That's what the threshold signature subnet is doing. It's signing, meaning it has a distributed private key for that Bitcoin address.
Okay.
So yeah, that's the distinction there.
Okay. Yeah, that makes more sense. And I guess this programmability. So what language are developers using to program? And is it Solidity? Is it what sort of language is being leveraged here?
Yeah, so this is another point where ICP has kind of done something a little different. It is a Wasm-based blockchain, and we're starting to see more of that as people kind of expand beyond Solidity. Wasm is really nice because you can do Rust, you can do JavaScript, and you can do Python. So, if we're thinking about onboarding the world of internet apps to a blockchain, why not give them a fantastic full stack JavaScript environment to build smart contracts, or full stack Python environment to do smart contracts. And so there are some benefits to having a Wasm-based environment in terms of just smart contract languages available.
So going back just a little bit, you mentioned this subnet, and you mentioned, numbers like 28 or 30, nodes in the subnet. What qualifies, decentralization? What number qualifies for decentralization? Is it more than 3? Is it 28? How do you know, how can you say that this is decentralized? What's the threshold for that?
Yeah, I don't view it as a binary outcome. You are, green check mark. Congrats, you are decentralized.
Yeah.
Mm-hmm.
I think it's a spectrum, and it's not even a static spectrum. It is a fluid spectrum.
Right.
And over time, as the actors in a network interact, you can actually move between centralization and decentralization over time. For example, if you look at, the Nakamoto coefficient, how many unique actors would need to be compromised in order to compromise a particular system. I mean, that's one way to view decentralization. You could also look at, on the Bitcoin side, you could look at the self-reported miner distribution of who is mining blocks. It is self-reported, so I mean, maybe an asterisk there on true decentralization numbers. And then on the Ethereum side, you could look at where people are actually staking their ETH, and look at the composition of different clients. So it's definitely very, very fluid in how you determine where a project sits on this centralization scale.
Yeah. Yeah, because back in the day, we used to really like EOS, and delegated proof of stake was what we thought was actually pretty smart, where I think how many nodes were there? Like
21.
21.
Yeah.
And I was like, well, this is sufficiently decentralized. Like, this is good enough. But yeah, I mean, EOS is like a completely different story at this point. But the point of like decentralization being a particular number, it is more fluid than just like absolute. And I think just achieving more than just a few nodes is pretty good enough for decentralization.
Yeah, and I guess it begs a question of like what activities actually you need to like interact with these subnets that I guess meet the criteria of like whether or not it's decentralized enough.
Right.
Specifically for those user inputs or whatever is being harbored and
whatever your product is, if a feature of your product is that it's decentralized, then this is you need that, right?
Correct. But nonetheless, though, this has direct integration to Bitcoin. So are there any like other potential like downside risks that we're not aware of when it comes to like leveraging ICP? That because from my understanding, there are like a lot of those downside risks for other, I guess, sidechain ecosystems or environments to Bitcoin that aren't like being like transparently talked about.
Yeah.
Right.
Yep.
Yeah.
So what would you say about that?
Yeah, so I would say in the ICP case, if you're going to come and leverage ICP to build Bitcoin tech, then you need to understand that you're trusting the nodes in this threshold ECDSA subnet, the 30 nodes. I mean, those 30 nodes essentially hold the private key for all of the cross-chain Bitcoin activity that's happening on ICP. And so that's kind of your first point of trust. The second one is the way that nodes get added or removed from that subnet is via on-chain governance.
Gotcha.
So ICP has one of the largest active DAOs in crypto, and everything is managed via on-chain governance. So this means all proposals have to be submitted, and the only way to upgrade the protocol, it's actually built in, the only way to upgrade the protocol is to submit a proposal and get it passed, and then that code change then gets propagated across all of the nodes everywhere. So this on-chain governance system is another point of trust.
Yeah.
You're trusting the this on-chain governance system that, I don't know, they're not going to do something crazy with the network.
Yeah.
So I would say those are kind of your two main trust points. You're trusting the decentralization and robustness and like incentive alignment of this on-chain governance, and then you're also trusting these nodes. The nodes in this threshold signature subnet are all known. They're all identified, so we know who they are, we know where they are, we know what business they're a part of. They're geographically distributed across the world intentionally, and so those are essentially your two main trust points when you interact with cross-chain applications on ICP.
Okay. And these subnets were they like deployed as ICP was deployed, or is there a mechanism to add more of them down the line for, I don't know, any reason?
Yeah, so there's a threshold Schnorr implementation coming this summer. Threshold Schnorr is like when you inscribe an ordinal, you have to use a Schnorr signature because you have to use P2TR, pay to taproot. When you inscribe an ordinal, that's mandatory. And so you actually need a Schnorr signature. And so you can't do that with the threshold ECDSA implementation because you need a new threshold signature subnet. So Schnorr is one example, and ECDSA is another example. Solana, for example, uses ECDSA signatures. Both of those are coming this summer, and it means that you'll now be able to, sign transactions for Solana. Canisters or ICP smart contracts will be able to hold Solana addresses. We'll be able to hold Solana directly. Also, you'll be able to inscribe ordinals directly from an ICP smart contract as well. The other benefit here is with ECDSA, there's a list of like 50 blockchains that use ECDSA signatures. Bitcoin, Litecoin, Dogecoin, Ethereum, Polygon, all of the ETH2s. And so the benefit here of these, cross-chain threshold signature subnets is, and I think this was part of the reason why Benny was interested in this tech, is you can deposit your Bitcoin assets into a TECDSA Bitcoin address, and then you can mint those assets on any Ethereum-based chain. So if you wanted to bridge BRC20 to Ethereum, it's actually a really nice way to do it because you can sign Ethereum transactions directly using this ECDSA subnet, and you can actually make HTTP calls directly from an ICP smart contract. So you can just interact. You can submit transactions directly to an Ethereum smart contract, and you can do all of this from an ICP smart contract. So it's a really elegant, kind of all-in-one packaged way to do cross-chain asset bridging.
Interesting. So what would you say is like the current state of ICP as far as like, developer adoption? Because it sounds, every time I look into ICP and I hear about it, it seems too good to be true. And I wonder why is the next iteration of DeFi not like happening here, right? Because as we've seen DeFi and Ethereum, there are some obvious attack vectors, right? Like those front end hosted interfaces that you talked about, right? Like those are real attack vectors, and we're seeing real DeFi founders getting like sniped by the DOJ, right? Yeah. So under ICP, that shouldn't happen, right?
Yeah, so I think if I was going to explain, why haven't we seen, a massive success of some kind of application on ICP yet, or why haven't we seen, an app with 1 million users or 10 million users? I think part of it is with any new blockchain ecosystem, there's like an infrastructure layer that has to be built. Think about Ethereum, think about Solidity, think about all of the smart contracts that exist already on the Ethereum side, and now take all of that away and, imagine having to rebuild it all. That's kind of what you have to do on ICP. That's also what you had to do on Solana. I mean, Solana tried to do this exact same thing, but Solana had the benefit of like massive capital injection from FTX and others that kind of got them over this infrastructure hump a lot faster. In the ICP case, there's just a lot of infrastructure that needs to be built in order to enable really nice protocol primitives that you can then build on as an application developer. And so I think part of it is it just takes time to build an ecosystem with enough tooling, enough infrastructure, with a stable enough protocol to then go and build a crazy successful application. I think it's also partly that ICP is very different in how they've made different trade-offs. Ethereum or Solana, they're a single machine execution environment. So what I mean is all of the transactions are ordered and they're executed in order. and then you get the next batch and you execute them in order. And so Solana's, max transactions per second is based on what a single machine can theoretically do, start to finish, just single threaded, essentially. Similar with like Bitcoin or Ethereum. ICP is an asynchronous blockchain. So this is another difference between ICP and other blockchains. Asynchronous meaning you have multiple subnets. We already talked about a couple subnets. I think there are like 35 subnets. These subnets can all talk to each other directly. There's just really nice, cross-subnet communication. And every subnet is almost like its own unique blockchain in that you only do consensus within your subnet. And so it's just like a broad stroke statement, I would say, is that ICP has made a lot of unique trade-offs to try to enable new kinds of functionality for blockchains. And that's just very different than the Ethereum model or the Solana model, for example. And so because it's different, there are a lot of people that just look at the price and say, oh, this is, bad tech. This is a terrible chain because the price went down. When actually it's just, it's a growing ecosystem. And I'm starting to see more and more adoption on the developer side, on the user side, as people come to ICP for the tech directly to try to do more with blockchains.
Could you say that a subnet is more like an application, like a decentralized application where a developer says, hey, I need an ECDSA signature. I also need a Schnorr signature because I'm doing a bunch of ordinal transactions. And so you leverage these decentralized apps in your product. Is that like the right way to look at it?
Yeah.
Okay.
I think that's accurate. Any ICP smart contract can make these cross smart contract calls. So you can call another smart contract directly, whether it's in your same subnet or whether it's in another subnet, it doesn't matter. You can just call it.
Yeah.
And you can interact with any of these services that have been already deployed on ICP. In addition to, if you look at what Chainlink is doing with oracles and bringing data on chain, because you can do HTTP calls in an ICP smart contract, it means you have easy Oracle functionality as well. Yeah. So whether you're calling another service or whether you're calling a Web 2 service, like you can just integrate it all together.
I see. So yeah, that makes sense because like let's say I needed on chain. Well, I needed the price of Bitcoin, right? You would leverage one of these subnets that is responsible for collecting the price of Bitcoin in a decentralized way, and you would call that function, right?
Yeah, so any individual application developer could actually build this, smart contract that is essentially like a Bitcoin oracle, Bitcoin price feed oracle. Yeah. And then anyone in the network could then interact with that specific smart contract.
Gotcha.
So it doesn't even have to be an entire subnet. It can just be a smart contract within one of the subnets, and then anyone can use it.
Okay, that's cool. Okay, so back in the day, we used to look into Cosmos and Polkadot. How would you say that ICP compares to these two?
Yeah, from a cross-chain or interoperability perspective, I think there are a lot of similarities in kind of what these chains are trying to accomplish. And I think there are some advantages to the threshold signature setup on ICP. Because you can interact directly with the blockchain and you can grab the data directly. It's almost like you have an oracle built in plus threshold signing, meaning you can interact with any chain directly. And so when you think about all of the things that people do with like light clients and having to run a light client proofs, and other like cross-chain communication problems, because ICP has these really nice protocol primitives, it actually makes it a really compelling place to build cross-chain interoperability because it's just all built in. Yes, you do have to trust, the Internet Computer Protocol. You have to trust this on-chain governance. You have to trust the nodes in these threshold signing subnets. But then that was my That was my 7-year-old telling me I have a wasp nest I need to spray outside. So that's what I'll be doing this afternoon.
Nice.
But yeah, all of these protocol primitives on ICP actually make it a really, really compelling solution for cross-chain interoperability.
Okay. Yes. Yeah. Because a lot of times, like, we're trying to, separate, layer zeros and layer ones and all this stuff. It's like, where does everybody fit in like this story, right? And hearing you talk about ICP, I get reminded of like Polkadot, because we used to be like kind of sort of bullish on Polkadot just because of its nature, right? It is supposed to be like the layer for everything, right? And ICP seems to be doing, similar-esque type things. And being able to bridge these two, like bridge existing blockchains and sort of like have a layer of access to each one, seems like a benefit. So my question to you is like, when you have like a BRC20 and you have this native asset on Bitcoin, if you will, bridging it to Ethereum or any other blockchain, like, do you see a lot of benefit in doing that, or do you think it makes sense to have like native assets and native functionality within like its own respective chain? Like, is bridging really like what we should expect in the full outcome of blockchain when you look back on it?
Yeah, I think that's a great question. There are two main theses for scaling blockchain right now. There's the monolithic thesis and there's the modular thesis. The monolithic thesis says, it's like this, it's like what Solana is doing. Let's just build a single blockchain that does it all, and we'll just continually upgrade, upgrade the protocol. Then there's the modularity thesis, and actually some people are, fighting for the modularity thesis over on the Solana side now as well. The modularity thesis is we'll have a settlement layer, an execution layer, and we'll have a data availability layer, and we'll have a prover, and we'll have a sequencer, and all together, we have all of these layers that you can then build a modular stack rather than a monolithic stack. One of the downsides of the modularity thesis is you end up with liquidity fragmentation across all of your layers.
Yeah.
Going from one ETH L2 rollup to another ETH L2 rollup is actually pretty hard because they each use different provers and different sequencers and maybe even different data availability layers. And so you almost have to wait for chain one to settle, and you have to wait for chain two to settle before you can actually actually bridge between them, which makes for a really annoying user experience. Like an atomic swap across two rollups would be really, really nice. And so some people are trying to do this with shared sequencing, kind of like what Espresso is doing. If you have shared sequencing, you can do faster bridging across rollups. We see protocols like Layer 0 or Wormhole or Axelar or others that are starting to go down this, cross-chain interoperability path. And, if you do pursue that modularity thesis far enough, you do end up with kind of the need for an interoperability layer of sorts. And on Bitcoin, especially right now, we have a host of sidechains posing as L2s. We have a host of sidechains posing as sidechains, and we have a bunch of metaprotocols. And, there's already, I think, a lot of liquidity fragmentation in the Bitcoin ecosystem.
Yeah.
And so one of the things that, I'm thinking about a lot, as I often dig deep into all these new chains and protocols. I think we do need kind of a layer 0 for Bitcoin. We have some people kind of dabbling in this area with like bridging BRC20s to Ethereum, or with this like tap integration, bridging tap tokens over to other chains. But I think we do need kind of a, bigger interoperability layer. And I think this is something that we might do with Bioniq, where we can kind of leverage all of this, awesome tech on the cross-chain interoperability side on ICP. And we can basically just enable, imagine all Bitcoin native assets, regardless of the meta protocol. Imagine all Bitcoin sidechains and all Bitcoin L2s. And you can just, move them between each other however you want. It's almost like the faster way to get from, BOB to Merlin, for example, is you could go through this interoperability layer rather than going back to Bitcoin and then going back up
I see.
to the other chain. So
Yeah.
I think there's an interesting opportunity here.
Yeah. I have a question for you that it's something that I struggle with. I talk to Iman a lot about it, and what I like a lot about Bioniq is sort of it brings the right and expected user experience for the end user, right? If you want an asset, as long as you have the correct a CKBTC in this case, you could just go ahead and buy it. You don't necessarily need to mess around with the Web3 stuff. You don't need a Web3 wallet. You just like log in with your email, and then you have like an abstracted version of a wallet. But what I was referring to was there was this conversation between the All In podcast interviewing Brian Armstrong, and they basically brought him onto the podcast, and it was like, okay, in Bitcoin or in crypto we have cycles that goes up and down, but they asked him, like, where are all the products? Like what? And so Brian Armstrong, I mean, he was sort of struggling to some extent. He was like, well, NFTs, those are products that brought in tons of people. And so if I were to ask you, like in the wider crypto scheme, outside of like programmable money, where are the products? Like, what would you say is a good product in crypto?
Yeah, I mean, I think this is a fantastic question. If you look at the current capabilities of Bitcoin, Ethereum, Solana, the biggest use case is tokens. You can create tokens, you can trade tokens, you can do some things with your tokens, and that's essentially what crypto is right now, for the most part.
Yeah.
And I think it's because of the way that blockchains work. It's very token centric, you could say. Meaning that, we have fungible token standards, and we have non-fungible token standards, and we have some like wallet. But I mean, I don't know, 95%, maybe more of crypto is just holding tokens and using tokens to do things. And that's kind of the extent of crypto. And part of this is probably because it's hard to do more than that.
I see.
Like branching beyond tokens, like what are you going to build on a blockchain that isn't tokens in some fashion? I mean, maybe DAO stuff, maybe stable coins. I mean, those are all kind of still token related.
Yeah.
But so from like a payments perspective with what we're seeing with stable coins, I think that's a really compelling payments use case. I think that's fantastic. From like a DAO perspective, I think there's also interesting use cases out there where you can actually use tokens to govern a protocol. And I think that's really interesting. But moving beyond that, I mean, this is kind of what ICP is trying to do. Like, how can we build a fully decentralized chat application? For example, there's one called Open Chat that's built on ICP, has tens of thousands of users, and it's all fully on-chain chat application. Like that starts to kind of scratch the itch of like, where are all the products? There's another social media application that is built fully on chain. I mean, Farcaster is another good example of something where you have a more decentralized social app. And so, I mean, I think it's a great question. I think it's going to take more time.
Yeah. And the reason why I ask is because when we were going through like the discovery of ordinals, I think around that same time, ChatGPT came out like a few months earlier.
Yeah.
And as soon as it came out, I mean, I just like technology. I like looking into everything. And you look into AI stuff, any website, it's like, they have subscriptions, right? We have a product. You pay for our product. You get, access to this AI that's supposed to generate pictures or whatever it is, right? And like instantaneously, there's a flood of these things. But in crypto, there's not a lot of that, right? And so I just I wonder, is like, when are we going to get to the point where it's not so much about the technology, where like owning tokens, like owning digital items, and like in our history of like gaming, like that's like a clear use case, right? But it's still focused on like the token aspect and not so much the product backed by the token, right? And so I'm wondering, it's like, when are we going to transition to that? And and get to the point where it's not so much technology, but like the result of the technology. Any thoughts on, man?
I mean, yeah, you're looking at the ultimate like question of this, because it's like Bob said, there's like still feels like we're in that infrastructure era of trying to figure things out. I don't think we can like derive like an absolute answer to that yet. I don't know. I mean, there's just like hints of it out there of like, you know, we're witnessing like little moments here and there where we're obviously striking a chord with like these different crypto offerings, which they result in products, right? Like, NFTs wasn't a bad answer from Brian Armstrong.
No, it wasn't.
It became a bigger product than the iPhone, right? As far as like annual revenue within that 1 year time span. And it's pretty significant considering like if we're in the infrastructure era, and that is like the value that can be produced from this like whole overall ecosystem. It's worth continuing down this path to see like what else we could do, right? Now that AI is like front and center stage, and you know, Bob is saying ICP can kind of like host everything, like the entire stack of IT. You know, we can have entire AIs living on chain.
Yeah.
Right? So it's kind of like a big deal. Well, what does that mean? Now we can actually run real simulations in the metaverse with real AI agents, right?
True.
Things like this, right?
That's true.
And who knows what that turns into, right?
Yeah, yeah.
Potentially GDPs surpassing real world countries as a result, and they're not even real humans.
Yeah.
Living out their own artificial lives, you know.
Yeah, so I guess finally, Bob, we're coming to a close here. I guess any final takeaways, talking about Bioniq, anything coming up, you know, on that side, anything that you're kind of interested in that you want the audience to know about?
I mean, we've covered, you know, we've covered a lot today, and I don't know that I have anything specifically. You know, I mean, we're heads down, still building like crazy on Bioniq. It's live right now. You can go in, you can easily convert. You know, it's just a single click to, well, I guess technically, yeah, maybe 3 clicks to convert Bitcoin to CKBTC. You wait the 13 confirmations, and you have CKBTC. And you can use that on Bioniq. It's all fast, very, very low fees. To do that, you don't need any new token. You just come in with Bitcoin directly. You pay the fees in Bitcoin. You transact on the marketplace. All fees are just paid in Bitcoin. So there's you know, no new token you need to have. Everything is built directly into Bioniq. Like we really tried to make the user onboarding experience very, very easy.
Yeah.
You know, just come in. We use Web3 Auth as kind of our, you know, self-custodial or non-custodial key management solution. So you can do like social logins and other things like that. So, you know, goal is, you know, how can we onboard 1 million people into the Bitcoin Ordinals, Runes, BRC20 ecosystem? And, you know, we're going to start with really, really fantastic user experience, you know, really fast applications, really nice design, and then probably branch out into more interoperability as L2s start to get more traction, you know, start to think about how we can kind of create some interoperability synergies across the Bitcoin native assets or L2 native assets or other Bitcoin sidechains. So, yeah, I mean, this is one of the greatest times ever to be building on Bitcoin, and I'm here for it.
I totally agree. Bob, thank you so much for joining us. You know, we really appreciate everything you do, especially on Twitter, the breakdowns, the analysis of like the new technology. We do rely on kind of like your take on whether or not like there's value in these like new proposals from people with like new meta protocols, new technologies. Yeah. And so, yeah, we really appreciate everything that you're doing. We're happy to have you back on with any updates with Bioniq or anything that you want to talk about. So, yeah, thank you so much for joining us, man.
Yeah, thanks for having me. Always fun.
Yeah, and for everyone else, all the links will be in the description. Thank you guys for watching the podcast, and we'll catch you in the next episode.
Peace.